Okay, so today what we're doing is we are going to be graphing functions. Now, with graphing functions today, we're going to be saying we want to check to see if the y-intercept, because that tells us whether the line is moved up or down, if we can figure out the relationship between this and our b term. Now that's going to be our y-intercept and the movement that it's made. So what we're relating to is this, y equals mx plus b. This b term right here being our y-intercept. We're going to ask ourselves, if I have a b, so we're going to see sometimes we're going to be adding, sometimes we're going to be subtracting, does that tell us if the graph has moved up or down, or does it relate to the graph at all? So we're going to solve a couple different graphs and see what type of relationship it has. Each one of these graphs, we're going to go ahead and we're going to label the y-intercept just to make it a little more obvious. Okay, so for the first one, we're going to take this function, and we know that with any function, we're going to build an xy table. Because before we know how to plug these in, we're going to have to do it by creating several different values. So I go from -3 to 3, and I'm going to plug those into my function. So I'm going to say 3 times x, well in this case my x is -3. So that's going to be 3 times -3. 3 times -3 is going to give us a -9, and we're done. So we're going to do that all the way down. 3 times whatever we want to plug in. So let's go ahead and get that set up so that we can plug in our numbers and go. Okay. So for this one, when I plug in a -2, we know 3 times -2 is going to give us a -6. When we plug in the next one, 3 times -1, 3 times -1 is -3. Here we're going to say 3 times 0. 3 times 0 is 0. 3 times 1, which is 3. 3 times 2. Again, we're plugging each one of these into here. 3 times 2 is 6. And for the last one, 3 times 3, which is going to give us a 9. So then I'm going to go ahead and I'm going to move this graph over, keeping my x values and keeping my final answer to clear things up so we don't get confused between what actually we're graphing. Okay, so I'm going to keep my -3, -2, -1, 0, 1, 2, 3. -9, -6, 0, 3, 6, 9. Perfect. So what I notice is that my extreme left and my extreme right are the same distance apart. So I'm going to go ahead and set up my vertical axis right here in the very center so that my left and my right sides of my graph are the same distance apart, just like my extreme numbers. Then I'm going to take a look at my extreme low and my extreme high. Again, they're the same distance apart. Negative and +9 are both the same distance from 0. So we're going to take our graph and we're going to put the horizontal axis, which separates the bottom and the top of the graph, directly in the middle so that we're, again, even. So if this is my x and this is my y, can I count to -3? Yes. Can I count to +3? Yes. So my x is going to be scaled by 1s. For my y's, can I count to +9? No, I can count to +5. So I can't do it by 1s. I'm going to have to do it by something a little larger. Let's try 2s. 2, 4, 6, 8, 9, 10. Yep. So 2s work. -2, -4, -6, -8, -10. Yep, they work. So let's go ahead and when we graph this, we're going to count to the left because we remember that a -x means left, a +x means right, a -y means down, and a +y means up. So I'm going to go left, and I'm going to count by ones. So 1, 2, 3. And I'm going to go down by twos. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere between 8 and 10 is going to be my negative 9. And I'm going to do that all the way down the table. Count left by ones, 2. Count down by twos, 2, 4, 6. Count left by ones, 1. Down by twos, 2. Somewhere between 2 and 4. Left by ones, down by ones. Draw that really big so you can see it. Right by ones, up by twos, so 2, somewhere between 2 and 4. Right by ones, 1, 2, up by twos, 2, 4, 6. Right by ones, 1, 2, 3, up by twos, 2, 4, 6, 8, 10. So somewhere between 8 and 10 is my 9. And we're going to go ahead and we are going to connect all these points with a line. A couple things that we do automatically here. Connect them all with a line, draw arrows on the end, and label it f of x. The next thing that we're going to do is we're going to label each point where it crosses an axis. In this case, it's that point in the center, and that point is at 0, 0. We know that's at 0, 0 because 0 on the x nets me 0 on the y. So we have no vertical movement. And let's look at our b term. What is our y-intercept? Well, I have the mx, but I don't have a b. So I have no b. So I have no vertical movement and no b term. So not telling us a lot there. So let's try something else. Let's try another graph. And this time, let's take that same graph, so 3 times the number, but let's add 2 to the end of it. So let's see what we get. So I've built an XY table. Take each value, -3, -2, -1, 0, 1, 2, 3. I'm going to follow the same set of steps that I did earlier, except for after I multiply by 3, I'm going to add 2 to each one of them. So 3 times a number. Then when I multiply by 3, I add 2. Three times what number for the first one? -3. -2, -1, 0, 1, 2, 3. Multiplying each one of these by 3 and then adding 2. Now this is going to be a 2-step process. 3 times -3 is -9 plus 2. Now -9 plus 2, that's a negative and a positive. I'm going to take the difference, which is 7. Keep the sign of the larger one, -7. Positive times a negative, -6. Again, with 2 different signs, I'm going to take the difference between 6 and 2, which is 4. Keep the sign of the larger one. -3 plus 2. I'm going to take the difference, which is 1. Keep the sign of the larger one. 0 plus 2. 2. Here I have the same signs, so I'm going to add them and keep the sign. It's a +2. 6 plus 2, I'm going to add them, keep the sign. +8. Add them, keep the sign. +11. Now over here, copy down my starting values and my final values. I'm going to look at my extreme left, my extreme right. Same distance away from 0. So I can go ahead and I can put my axis the same distance away on each side. So -3 and +3 are the same distance away, so my graph is right in the center. Now here, I notice that my positive number is bigger than my negative number. So I'm going to leave, instead of keeping it directly even, I'm going to scooch this down just by 1 bar. If it was a little bigger, maybe that was like a 13 or a 14 or even a 15, I might scooch down even farther. But it's an 11, so it's not too far away from 7. But I'm going to scooch it down just a little bit. Okay? And again, we remember the fact that negative x's mean left, positive x's mean right. Negative y's mean down, positive y's mean up. Okay? So I need to go to -3 and +3. 1, 2, 3, that works. 1, 2, 3, that works. So my x can be by 1s. It's a weird S, but we'll make it. So my x is by 1s. My y values, I need to make it down to -7. 1, 2, 3, 4. Nope. How about 2, 4, 6, 8? That works. Let's try 2's going up. 2, 4, 6, 8, 10, 12. Yep, that works. So my y is by 2's. At this point, we're going to do what we did before. I'm going to go left 3, but I'm going to count by 1s. So 1, 2, 3. I'm going to go down 7, counting by 2s. So 1, 2, 3, 4, 5, 6, 7, 8. Ooh, right before we hit 8. Left 2, down 4 by, and I'm going to count by 2s. So 1, 2, 3, 4. Left 1, down 1. 0, up 2. So I'm going to make this a little bigger so you can see it behind that axis. 1, up to 5, and I'm counting by 2s. So 1, 2, 3, 4, 5. Right by 2s, or right by 1s, 2, 2. So 1, 2, up by 2s to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost to 12. Okay. There's a couple things we're going to do here. We're going to go ahead and connect this with a straight line, draw our arrows, and label it real quick. Awesome. We know that there are 2 points where it crosses. One where it crosses the y-axis, and one down here where it crosses the x-axis. This point is going to be right there at 0, 2. That point we're not going to figure out yet until a later topic. We'll get it, but not today. Okay, so if our graph was at 0, 0, now it's at 0, 2. So where did it move? Well, it moved up 2. So we moved up by 2. And what is our b term? And the b term is positive 2. Okay, so we moved up 2 and the b is positive 2. I think we might be onto something. Let's try one more before we actually say anything definitively. Let's, instead of saying +2, let's say -2, the exact opposite of what we said before. So why don't you go ahead, build your table, graph your points, and see if you can't make a prediction about that rule of what do you think a -2 is going to do to our graph if a +2 moved up 2. See if you're right. Okay, so we're going to give this a shot. So I'm going to plug in some values. -3, -2, -1, 0, 1, 2, 3. I'm going to multiply the number by 3 and then subtract 2. So multiplied by 3. Each of these numbers I'm multiplying by 3 and then subtracting 2. So 3 times negative 3 is negative 9. 3 times negative 2 is negative 6. Negative 3, 0, 3, 6, 9. So 2 negatives. I'm going to add them together. 11. Keep the sign. 2 negatives, add them together. Keep the sign. 2 negatives, add them together. Keep the sign. That's neither a negative nor a positive, so that's just going to be a negative 2. Now we're back to different signs, so I'm going to subtract. 3 minus 2 is 1. Keep the sign of the larger, positive. Different signs, so the difference between 6 and 2 is 4. Keep the sign of the bigger, positive. Different signs, so subtract. Difference between 9 and 2 is 7. Keep the sign of the larger, positive. Awesome. Okay. So when I look at my extreme cases, negative 3 and positive 3 are the same distance away from 0. So I'm going to go ahead and I'm going to put my vertical axis right here. So now that the left and the right are the same distance away from 0. Now my y values, I have a bigger negative than positive, which means I'm going to scooch the graph up a little bit to give myself some more room on the bottom. I'm not going to scooch it up too far. Just a little bit. That's my x, that's my y. So I'm going to take my x. Can I count to negative 3? 1, 2, 3. And positive 3? 1, 2, 3. Yep, so my x can be by ones. For my y's, can I count to negative 11? So 1, 2, 3, 4, 5, 6. Nope. Let's try by 2's. 2, 4, 6, 8, 10, 12. So yes, I can count to negative 11 if I count by 2's. Let's try and make sure that it works on the top. Can I count to 7? 2, 4, 6, 8. Yep. So I'm going to count by 2's. Okay. So we know that the negative x means left. Positive x means right. Negative 11 means down. Positive y means up. So let's graph this. I'm going to count left and right by ones. Count up and down by 2's. So left, 1, 2, 3. Down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Left 2, down 8. So 1, 2, 3, 4, 5, 6, 7, 8. Left 1, down 5. So 1, 2, 3, 4, 5. 0. Negative 2, again, I'm going to make this a little bigger. 1, 1. 2, 1, 2, 3, 4. Right 3, 1, 2, 3, up 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to do a few things here. We're going to connect all of our points. Straight line. Draw arrows on the end and label our function. And we're going to label that intercept and this intercept. Now this x-intercept, we don't know about that in this lesson. We'll figure that out in a future lesson. But this one, well, my x is 0, which means it's got to be that. So 0, negative 2. And so from our starting graph, 0, 0 to 0, negative 2, well, that means that we moved down by 2. And then we're going to look at our b term. What's our b term? and the b term is -2. So think about that for a second. It moved up when it was +2, moved down when it was -2. So I want you to make a prediction of what's going to happen to this graph right here. Most likely, you'd probably be right if you've caught on by now. That +10, well, that means that that is going to be up by 10. So this graph is going to be shifted way up on the axis. And so there we go. Okay, so let's try a few more, except for this time, let's try it with negative values. Now, the question is, do negative values work the same? Would that be an upward movement, and would that be a downward movement? Or do the negative values out front change it? Well, there's only one way to find out, and that way is to graph them. Let's go ahead and let's set up a few. So we're going to set up our XY tables, and we're going to plug in our numbers. So -3, -2, -1, 0, 1, 2, and 3. So multiply each number times a -2. So no matter what it is, our function says that we need to evaluate out everything that we plug in and multiply it times a -2. So this -3 is multiplied by -2. This -2, this -1, the 0, every number is multiplied by a -2. So now a negative and a negative make a +6. Negative, negative make a +4. Negative, negative make +2. 0. A negative and a positive, when I multiply them together, that gives me a -2. -4 and a -6. Boom, there we go. So we're going to rewrite this table over here with -3, 2, 1, 0, 1, 2, 3, 6, 4, 2, 0, -2, -4, -6. Awesome. So we're going to check our extreme values. These are the same distance away from 0. So again, we're going to set our axis right in the center of our graph. There's our y. And when we look at our x's, we notice the same thing. +6 and -6 are the same distance away from 0. So I'm going to put our horizontal axis right in the center of our graph. X. Perfect. And we remember that negative means left and positive means right. Positive for the y means up. Negative for the y means down. So these first few we're moving left and up, and for the last few we're going to be moving right and down. Okay, so let's go ahead and in a different color. I'm going to move, well, hold on. Got a little ahead of ourselves. I need to put the scale down. So can I reach -3? 1, 2, 3. Yes. Can I reach +3? 1, 2, 3. Yes. So I can count by ones. Can I reach 6? 1, 2, 3, 4, 5. 5? Sorry, 1, 2, 3, 4, 5. Nope. So how about by twos? So 2, 4, 6. Yes. How about by twos negative? 2, 4, 6. Yes. So my y is going to be by twos. So when I count over, I'm going to be counting by ones. When I count up and down, I'm going to be counting by twos. So when I say left 3, 1, 2, 3. When I say up 6, I'm counting by twos. So 2, 4, 6. Awesome. I'm going to go left 2 and up by twos until I hit 4. 2, 4. Left 1, up 2. And then this point right here, I'm going to draw really big so you can see it. Right 1, down 2. And again, the graph works in the negative direction. I count to the right by ones and down by twos, so 2, 4. Right by ones, down by twos, 2, 4, 6. Awesome. So the first thing that we're going to do is we're going to go ahead and we're going to connect all these points with a straight line. and I'm going to put an arrow on each end and label this. So f of x. There we go. And now the point that we're tracking today is when it crosses these axes. So this point right here, it's at the center, so I know it has moved left to right, so it's going to be where my x is 0. So it's at 0, 0. And so this is my starting graph. Nothing's been added, nothing's been subtracted. So we have no movement. And our b term doesn't exist, so we have no b term. So that's kind of what we expected. We said, hey, no vertical movement, no b term. However, we do notice the graph is downward as opposed to what we had earlier where the graph was going up. We noticed with the positive values, the graph went up. So in this case, my negative values, the graph is going down. So let's see. We're going to try out the next one, and we're going to see if the negative value means that that moves up or down and see what we get. So again, we're going to make a table of x and y's. We're going to plug some numbers in. I'm going to multiply these numbers by -2 and then add 5. So I multiply them all by -2. And then I add 5. Okay, so I'm going to multiply this number by -2, this one, this one, this one, this one, this one, and this one. And when I'm done, I'll add 5. And conveniently, I kind of already have a guide of what these numbers multiplied by -2 is. So the first part is going to be 6, 4, 2, 0, -2, -4, -6. But I haven't added 5 to any of these. So I'm going to have to put the +5 on each one of them. But it did save me a step, because in evaluating out this, I know what the first term is. Okay? So for 6 plus 5, I have the same signs. That's going to make an 11. They're both positive, so it's a positive 11. Same sign, so add, keep the sign, positive. Same signs, add, keep the sign, positive. Positive. Different signs, so I'm going to subtract. 5 minus 2 is going to give me 3. Keep the sign of the bigger one, positive 3. Different signs, so I'm going to subtract. 5 minus 4 is going to be 1. Keep the sign of the bigger one, positive 1. Different signs, subtract. 6 minus 5 is 1. Keep the sign of the bigger one, -1. So we notice down here that positive, negative, I take the difference between the numbers, which 4 and 5 is 1, 6 and 5 is 1. But because the 5 is bigger here, that's a positive 1. And because the 6 is bigger here, that's a -1. Awesome. And so now let's move these numbers over. Perfect. Now let's look at our extreme values. So my left and my right, they're the same distance away from 0. So we're going to go ahead and we're going to put our vertical axis right here in the center. Okay, that is my y-axis. Now, my y values, that 11 is way farther away than -1. So what we're going to do, because this is so much farther away, I'm going to move my axis almost all the way down. I know that with one block, no matter what I count by, -1 will fit right there. So my x is going to be way down there. That's going to give us some more room. And let's take a look. We remember that -x means left, positive x means right, positive y means up, and the single number is down. So we see most of the graph is going up, a little tiny piece of it's going down. Let's go ahead and Let's double check our scale. Can I count to -3 and +3? 1, 2, 3, yep. 1, 2, 3, yep. So my x's by ones. Can I count to 11? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Can I count to 11 by twos? 2, 4, 6, 8, 10, 12. Yes. Can I count to -1 by twos? -2. Yeah. So twos work. So we're going to go left by ones and up by twos. So 1, 2, 3, up by twos, so 2, 4, 6, 8, 10, 11. Left by ones, 1, 2, up by twos, 2, 4, 6, 8, 9. Left by ones, up 2, 4, 6, 7. 0, 2, 4, 5. I'm going to draw this a little bigger so you can see it behind the axis. Right by ones, up by twos, so 2, 3. Right by ones, 1, 2, 1, 1, 2, 3, and down right here. Perfect. So we're going to connect these points with a straight line. We're going to draw an arrow on each end and label it. So f of x. And now we have two intercepts. I have this intercept, and I have this intercept. This intercept is right in the center, so I'm going to find where my x is 0. Right there. So that is 0, 5. This intercept right here, we haven't figured that one out just yet. We will figure that out in a later video. So when we ask ourselves, where did the graph move with no b versus a +5? How did that point change? Well, it moved up from the center by 5 units. So we moved up 5, and our b term is +5. So instead of writing +5, I'm going to put +5 this time. If our b term is +5, we moved up 5. So does the negative have any effect from what we discussed earlier? We moved up 2 when it was +2. We moved up 5 when it was +5. So does the negative have any effect on that? No, it doesn't. Which means that I want you guys to try number 7. Pause the video, unpause it when you're done, and see how well you did, knowing what that negative is going to do to our graph. Okay, unpause it when you're done and see how you did. Okay, so let's go ahead and let's get this one started. I'm going to set this up, -3 to +3. Those are our generic points. I'm going to multiply them all by -2. And then I'm going to subtract 4. I'm going to plug all these numbers in. Awesome. And so we have a slight way that we can kind of cheat a little bit ahead on this because we've already done that first step where we've multiplied all these numbers by -2. So I know the first step is going to be the same. 6, 4, 2, 0, -2, -4, -6. What I haven't done is I haven't subtracted 4 from these numbers. So I'm going to have to do that by hand. So I have different signs, so I take the difference, 2. 6 is bigger, so positive. Difference, 0. Well, no sign on that one. Different signs, positive, negative, so I take the difference, 2, but in this case, 4 is bigger, so -2. -4. Same signs, so I add them together. 2 and 4 make 6, and I keep the sign of negative. Same sign, so I add them. 4 and 4 make 8, keep the sign which is negative. Same signs, add them together, keep the sign which is negative. Now I'm going to copy these two extreme values over here. Perfect. And we're going to check out our extreme values. -3 and +3, same distance away from 0. So we're going to set up our graph. So it's right smack dab in the center. Now with the y's, I notice that -10 is way farther away than my 2. So what I'm going to do is, opposite of what we did right here, I'm going to move my graph way up. So let's say right here. I could probably move it up one more square, but I'm not 100% sure that I'll be able to have enough room. This allows me more room on the bottom for these big old negatives, and a little bit of room on the top for that one positive number. Okay. Let's not forget that negative x's are left, positive x's are right. The positive y is up, negative y is down. So notice that I have a lot of room for my negative y's, little room for my positive y. I've got about equal for my left and right. Okay. We're going to check our scale. Can I count to -3? Yes. +3? Yes. So my x is going to be by 1s. Can I count to 2? Yes. Can I count to -10? 1, 2, 3, 4, 5, 6, 7, 8. No. So I'm going to have to change the entire scale. So how about by 2s? 2, 4, 6, 8, 10. Yes. So I'm going to count everything by 2s. So let's go ahead and graph. I'm going to move left by 1s, so 1, 2, 3, and up by 2s, so 2. Left by 1s, up by 2s, which in this case, there's nothing. Left by 1s, down by 2s, so 1, 2. Right there. Right by 1s, down by 2, so 2, 4, 6. Right by 1s, 1, 2. Down 2, 4, 6, 8. Right by 1s, 3. Down by 2s, 2, 4, 6, 8, and 10. So we are going to connect all these points real quickly with a line. We're going to draw arrows on the end of our line and go ahead and label it f of x. Awesome. So we've got our line graphed. Now what we're going to do is we're going to label our two intercepts. This one, conveniently, we actually have this one this time. This is going to be where the y is 0. We have that point right there. That is -2, 0. This point is where the x value, this one, is right in the middle, so where x is 0. So this is 0, -4. Now, this tells us our left-right movement, in which case we're not too concerned about that. We're just concerned with the up-down movement. So from our normal graph of 0, 0, where did that point move? Well, it looks like it moved down 4. So let's write that out. It moved down 4, and the b term, what is that? Is -4. So +5 is up 5, -4 is down 4. Boom. Hope you saw that. So in the future, what we're going to be doing is we're going to know that we can move the graph up and down based off this parent function, based off if the b term is positive or negative. And there we go.